Hi everyone, welcome to the Earth Science Regions Review podcast series created by Hammock's Middle School Earth Science Department. Today we're going to be talking about metamorphic rocks. Now metamorphic rocks are a unique type of rocks that can be found in a specific area on the Earth. But before we get into that, we need to talk a little bit about the features with your metamorphic rocks. Your metamorphic rocks, just like igneous and sedimentary, they're going to be organized or classified by texture. Texture meaning the actual mineral crystals within the rock. Now those mineral crystals can either be foliated or non-foliated. We'll talk about the difference between them a little bit later on in this podcast. Now these rocks are going to be important because they're formed solely by heat and pressure. Where are you going to get that heat and pressure from? Convergent plate boundaries. Due to that intense heat and pressure, your mineral crystals tend to be recrystallized, meaning that they're going to organize themselves within the rock based upon density. So they tend to kind of zone themselves up. So what's going to happen here is because that intense heat, intense pressure, those rocks tend to be the most dense out of any rock type that we have on the planet, very simply because of the pressure squeezes those molecules close together. These rocks tend to be made without melting. If these rocks get heated enough where they're going to melt, they're going to turn into igneous. So there's a fine boundary between metamorphic rocks and igneous rocks in relation to the heat involved. Now these types of rocks are going to be basically found in true mountain ranges, such as the picture here, which represents a continent-to-continent convergent plate boundary, which would represent India crashing up to Asia, creating the Himalayan mountains. Your Himalayan mountains are true metamorphic rock, and there's going to be some characteristics that you look at in order to identify a true metamorphic rock. Now, there are two different types of metamorphism that a metamorphic rock undergoes. The first type is what we call regional metamorphism. These are really going to occur at convergent plate boundaries, specifically where you're going to get continent-to-continent convergence. Regional metamorphism just means that the metamorphism of the rock occurs over a massive area, usually found within mountain ranges. Now, the true name for a mountain range is what we call an orogeny. So there's certain mountain ranges on the planet where orogenies actually have existed. That's where your true metamorphic rock is going to take place. And again, this is where the intense heat and pressure is going to be found. Now, with your regional metamorphism, now you're going to get into what's called a foliated rock. Because of the intense heat and pressure, what's going to happen here is these rocks are going to have some sort of mineral alignment or some sort of mineral banding. The minerals are going to align themselves up into rows in the sense that you are going to see a specific pattern within the rock. Now, some rocks have microscopic crystals that are really hard to see. Other rocks, it's very clear in terms of the foliation that takes place. Most foliated rocks will be somewhat polymineralic, meaning that they can be made up of more than one mineral. Now, if we're going to go through the metamorphism of rock, you usually start out with a sedimentary rock like shale. If shale undergoes a little bit of heat and pressure, it changes into a rock called slate. Now, slate shows mineral alignment, it shows foliation, but they're so tiny, they're so microscopic, very hard to identify. You go a little bit deeper into the planet, and what's going to happen is you're going to get a rock called phyllite. Now, phyllite does show mineral alignment, does show some sort of foliation, but again, there's quite microscopic, a little bit hard to see. You go a little bit deeper into the planet, you come to a rock called schist. Now, schist definitely shows mineral alignment, definitely shows foliation, and you can actually see it without the aid of a microscope, very simply because you're starting to see the microcrystals starting to align themselves up. You go a little bit deeper into the planet, just before a rock is going to melt, you're going to get a rock called gneiss. And gneiss shows the big, beautiful bands, the beautiful foliation, an extreme form of mineral alignment called foliation. That foliation specifically is called banding. And that banding is going to be very apparent throughout the rock. You see these beautiful stripes throughout the rock. That's going to just be an indication of the different minerals that have aligned themselves up. So usually you could take a rock of granite and take a rock of gneiss, and you see the differences between them. Even though granite is an igneous rock, there's no pattern with the mineral crystals. Gneiss is a metamorphic rock. There is a pattern with the mineral crystals. So really important to be able to identify the differences between the two. And an easy way to remember it is you look at the rock gneiss. Gneiss has nice stripes, just like a tiger will have nice stripes. So an easy way to remember the striping pattern or the banding pattern within the rock gneiss. So there is some evidence for regional metamorphism with these foliated rocks. Sometimes these rocks are going to show mineral alignment, but they're also going to show some sort of deformation within the rock as well. If the rock has a wavy pattern to it, we say the rock is folded. If the rock is broken, we say it's faulted. And if you say that the rock is out of its original horizontal position, we say the rock is tilted. That's what we call deformation within the rock. So if your rocks look a little bit messed up, some sort of metamorphism is most likely taking place within that rock. With regional metamorphism, what's going to be important here is to understand the sequence of regional metamorphism. The lowest grade of metamorphism is going to be slate. So you take a rock shale, you change it to slate. You as you go deeper and deeper into the earth, you're going to finally get to a rock called gneiss. That's going to be the point right before a rock is going to melt. And what happens here is that the degree of metamorphism increases as temperature and pressure increase with depth. So again, that's going to be taken right out of your reference table. Very important to check out that podcast as well. But again, you need to know that sequence of metamorphism with the regional type of metamorphism. The second type of metamorphism is called contact metamorphism. And this is going to occur in areas with a lot of volcanism, a lot of magma, a lot of lava going on. So this is basically, the name kind of explains itself, it's where magma or lava is going to come in contact with the rock. It's going to touch the rock. Well, because of the intense heat from the lava or magma, that lava or magma is going to bake the rock that's touching and alter it into a new rock. Now, these rocks are not nearly as dense as your regional rocks, very simply because you just don't have the intense pressure. So with your contact rocks, where this is going to take place is where your magma deep below the surface or your lava at the surface is going to touch the rock. And at that contact point, the rock is going to be altered and is going to change. These rocks tend to be called non-foliated rocks, very simply because you don't have the pressure that's going to cause the minerals to align themselves into rows or bands. So what's going to happen here is that the non-foliated rocks are basically going to form through the intense heat from magma or lava. Okay, there is going to be an alteration within the rock. The rock is going to change, but there's not going to show any pattern whatsoever within your rocks. Okay, so no mineral alignment here. These rocks are a little hard to identify because of that. These rocks also tend to be monomineralic in nature, meaning that they're made up of one mineral. So you can get a rock called conglomerate, which is sedimentary in nature, okay, can change into a rock called metaconglomerate with the stretched out pebbles. Now this rock can be made through regional metamorphism, or it can be made through contact metamorphism as well. The rock hornfels is the only rock in your reference table that you need to know is solely made through the contact metamorphism of magma or lava. Now the rock in which it comes from can be a variety of different rocks, but hornfels is only made solely through the contact metamorphism. You get a rock called limestone, which is sedimentary, and that's going to alter into marble. Again, that can be made either through regional metamorphism or contact metamorphism. You can get a rock called sandstone, which is sedimentary. That can be altered into quartzite. Again, that can be either regional or contact metamorphism. Get a rock called bituminous coal. That can be altered into anthracite coal. Again, either through the regional process or the contact process. So the majority of rocks can be altered. Your non-foliated rocks can be altered through both processes, either regional or contact, with the exception of hornfels. So please make sure you go back into page 7 in your reference table. Make sure that you look at the metamorphic rock chart and understand how to use it. Okay, that's it for now. Talk to you soon.